Today is the last lecture of the ellipse chapter. So till today we have learned many concepts starting from basic level till very high advanced level. And today we will mix all those concepts and solve some problems. But before that, there are some important points that you need to remember. So first thing is, after every chapter you need to practice at least 5 to 10 questions per every concept. For every concept, you need to first understand the concept, that is the concept building stage, and then you need to develop some skills, that is the skill development stage. So to understand the concept and digest it, you generally take 3-4 questions. After that, to develop skill, you need 3-4 more questions. So that is why you need to practice 5 to 10 questions per every concept. Now, having said that, if we take the total number for the entire chapter, so the total number may go up till 100. So in mathematics, on an average, for every chapter, you need to solve around on an average 100 questions to master that chapter. So remember this, if you are solving let us say 40-50 questions, and if you are still feeling confident that you can do all questions of that chapter, remember that maybe you are missing a point, maybe you are missing a concept. Okay. So now this is how you master one chapter. But once after you solve let us say 10 questions on a single concept, you might have observed a pattern. So there is always a pattern of questions. As I keep saying, mathematics is full of patterns. So based on the patterns that you have observed in the problem solving, you need to make some notes, because there are some questions which can be attempted only in a certain way. There are some questions which can be attempted only using basics. So you need to shortlist these methods and list them as your algorithms. Okay. So that is second task. Second task is to understand the pattern and to list down methods for those patterns. Now the third task is, after you practice questions, see we have done the chapter till now, by today we will finish the entire ellipse from teacher's side, but from student side there is still lot of work that is to be needed, and that means you need to practice more and more questions offline at your home to master the topic. After that stage is completed, then based on your experience, shortlist around 15 to 20 questions, or let us say 10 questions also would be fine. So let us stick to one number, let us say 10 questions. So shortlist 10 questions from the chapter ellipse and list them down in your personal notebook where you are writing your algorithms. Now whenever in future, after few months, let us say you want to remember ellipse, generally students have the habit of forgetting things. So naturally you are going to forget after 3-4 months. So after 3-4 months, if you want to revise ellipse, what is the best way? Reading notes and solving problems? Of course no. You just have to solve those 10 questions you have shortlisted. So shortlist those 10 questions in such a way that they cover all concepts, and also they cover all ideas of problem solving. So that is your quick revision plan. So always make a list of 10 questions for every chapter, so that at later stages, if you want to revise, you just solve those 10 questions and revise the entire chapter. Okay. So these are 3 tasks for you. After today's lecture, you are going to do these 3 tasks and you are going to close the chapter ellipse after you practice questions. Okay. Now shall we start? So today I tried to mix questions both from mains and also advanced point of view. So let us try to solve them as many as possible. Okay. So there is this first question, PQ is a common tangent of these two. This I think we have solved in the English lectures. This we have not solved in Hindi, so we kept this. So if you let us say want to go through different languages also, you can watch Hindi, you can also watch English. Okay. So let us go to the next question. So find the area of the quadrilateral formed by common tangents to these ellipses. In general, how do we find common tangent of any two curves? So here the two curves given are two ellipses and we want to find common tangent. What is the best way? So here is one sample of algorithms that I was talking about. So there are different cases. Case number 1, is two circles. If two circles are given, how do we find common tangents? So, what is the method here? First find the points of similitude and then using the method of finding tangents through an external point, find the common tangents that are required. Okay. So, for two circles there is a method, that is one algorithm. For any other two curves, okay. So, if both curves are not circle, if both are not circles, then there is one method. What is the method? First write equations of tangents in slope forms. Okay. So, let us say y equal to mx plus something, this is the condition on C, and for the next curve we will get something else here. First write the equations of tangents in slope forms like this, then equate the C. Okay. After you equate the C, you will get some solutions of M. After solving for those solutions, if you put those solutions back in the equations, you can get the common tangents. For example, let us say we have one parabola and let us say we have one circle and we want to find common tangents. What is the best way? Follow the same process. So, what happens to the equation of tangent of parabola in slope form? This is the equation. Similarly, equation of tangent to the circle will look like this. Now, what is our next step? Equate C. So, that means we have to equate A by M with plus minus A into root of 1 plus M square. If we solve this, we will get values of M. Now, depending on how many tangents are possible, we can get the number of solutions of M. Now, after you get the values of M, you have to put the values of M back in the equations of tangents and get the tangents. But because there is plus minus sign here, it might confuse you. Okay, so, it might confuse you. So, you have to put the values of M in the equation which gives you less confusion. For example, in this equation of tangent of the parabola, there is no sign confusion, there is no plus minus confusion. So, after you get the value of M, put this value directly in this to get the equations of tangents. So, that is the way to find common tangents of any curves. Okay. So, here is a method, here is a list of algorithms, you have to make these as notes in your personal notebook. Okay. So, come on, take a snapshot of this. Okay. So, now let us solve this problem. What is given? Find the area of the quadrilateral formed by common tangents of these. Now, without loss of generality, let us assume that A is greater than B. Even if you assume that B is greater than A, it does not matter. Okay. So, now we want to find the equations of common tangents and hence the quadrilateral. So, algebraically if we want to find common tangents, what is the procedure? We have just learned the algorithm. So, write the tangent to this, it will be y equal to mx plus minus root of a square m square plus b square. What about the tangent to the next one? It will also be in the same lines, but here if you observe a and b are reversed. So, just swap a and b here. So, you will get b square m square plus a square. Okay. So, now we want to solve for m. So, equate these two, plus minus root of a square m square plus b square is equal to plus minus root of b square m square plus a square. Now, if we square this, we get a square m square plus b square is equal to b square m square plus a square. Okay. Now, try to solve for m. So, I will take all terms with m in LHS and all constant terms to the RHS, and luckily a square minus b square is cancelled and hence we are getting m square equal to 1, which means m equal to plus minus 1. Okay. So when I put m equal to 1 here or minus 1 here, I may get common tangents. But plus minus sign is confusing. For example, I got two slopes here and there is plus minus here. So total how many possibilities are there? 2 into 2, total 4 possibilities are there. So that means I should be getting 4 equations of common tangents. Now let us verify this geometrically. So if I draw the first ellipse, it will look somewhat like this, and if I draw the second ellipse, it will look somewhat like this. So basically we got two ellipses. Now how will the common tangents look like? We have one common tangent here, we have one common tangent here, one common tangent here, one common tangent here. So our algebra was right. So as I keep saying, every equation in algebra has a meaning in geometry, every structure in geometry has a meaning in algebra. So that is the beauty of coordinate geometry. Beauty of coordinate geometry is to connect geometry with algebra. Okay. So now we have understood this idea. Now further, what kind of quadrilateral this is going to be? To understand this, we can directly look at the equations and observe symmetry there. Because A and B here are same, A here is same as A here, B here is same as B here. And also if you look at these two equations, in one equation if I swap x and y, I can get the other equation. That means if I reflect one curve about the line y equal to x, I will get the other curve. So the entire diagram collectively is symmetric about y equal to x line. So if it is symmetric, then tangent is also symmetric about y equal to x line. So that means this has slope 1, this has slope 1, this has slope minus 1, this has slope minus 1, because these lines are symmetric with respect to x and y axis. Okay. So even without solving this algebra, we can conclude this from the geometry itself that the tangents are going to be symmetric about x and y coordinate axis. So that means if I join these two will be the diagonals and they will bisect each other, and tangents are also of equal lengths. How am I concluding this? Only by symmetry. And because this line is symmetric, this line is also symmetric with x and y coordinates, these two angles must be equal. So it forms a rhombus, because because this has slope 1, this has slope minus 1, it forms right angle here. So the quadrilateral is square. See, using geometry itself we could conclude that the quadrilateral is going to be a square. So there is algebra here, there is geometry here. I explained using pure geometry also, and I connected both of them also. Now let us go back to the question. So here the question is, find the area of the quadrilateral. So here if I notice this triangle when reflected 2 times is going to give me these triangles. Okay, so that means to find the total area, I just have to find the area of this small triangle and multiply that with 4. Now how do we get this area? Just get the x-intercept of this tangent and y-intercept of this tangent, and then just apply half base into height. So how do we do that? Because this line is going to have slope equal to minus 1. So in any one of these two equations, just put m equal to minus 1 and take only one sign, either plus sign or minus sign, just take any one sign, it does not matter. So let us say I am taking this plus sign, and if I put m equal to minus 1, so what am I getting here? Y plus x equal to root of a square plus b square. Now whatever I get as x-intercept will be same as y-intercept, because here we concluded that the line is symmetric, so whatever is this length is going to be same as this length. So this triangle is going to be a right angle isosceles, that is by pure geometry. So here also we can observe it using algebra. If I put x equal to 0, I will get one value, if I put y equal to 0, I will get another value, but these two values are same. So now we just got the intercepts as a square root of a square plus b square. So that means the area is going to be 4 into half into base into height. Now base and height are basically same, so we will just write them here, and then hence we can write the area as 2 into a square plus b square. So solving the question is, it can be through any method. Solving the question is immaterial for you. What is important for you is the methods. So what is the method here? What is the geometric method here? How did we connect algebra with geometry, and how did we solve the problem? Okay. So I hope you have liked this problem. Come on, make a note of this. This page also. Okay, so now let us go to the next question. So here a variable ellipse has one focus fixed and touches two fixed intersecting lines. The locus of its center is. So I think this at this question we stopped in the last lecture. So we will complete the question today and we will move on. So what was the idea? So here if you look at the options, we are never interested in the equation, we are interested in the shape of the locus. So then what to do? Shift the entire situation to origin, it is better that way. Okay. So I am going to shift the entire situation to origin. So let us say I have taken one ellipse here. Okay, so we have to take two fixed intersecting lines. Now let us take this point of intersection of lines as the origin. Okay, and let us take two lines here, one line here, other line here. Okay. So these are two tangents. So basically I have taken this as the origin and I have taken x axis here, and what is to be fixed? It has one focus fixed. So let me take the focus as, let us say, some a comma 0. Okay. This is my focus and these are my lines. Lines are also fixed, these are intersecting lines. So I can take equations of these lines as, because they are passing through origin, so y equal to mx is one line, y equal to minus mx is another line. Why did I take the symmetric lines? My wish, my problem. Okay. Because here, irrespective of whether this entire situation is located somewhere or rotated somewhere, the locus is going to be one fixed curve. If it is parabola, it will stay as a parabola only. So I have set up the entire system on origin and that too with symmetric lines. Okay. So now one focus is fixed, which I have taken as a comma 0 on x axis. Now I will apply the question. So it touches these two lines. Okay. So variable ellipse has one focus fixed and touches two fixed intersecting lines. Then locus of its center is. Okay. So we have to find the locus of the center. Okay. So now this ellipse could be tilted also. Okay. It could be tilted also. It could be lying on this line also. So we don't know. Okay. So let me take the center as some h comma k. So let us say this is my center, which is h comma k. Okay. So we know that perpendicular distance of this point. Okay. So not the perpendicular distance. So we know that perpendicular drawn from focus to the tangent lies on eccentric circle. So from here to here, if I take the distance, it has to be equal to the length of semi-major axis. So because I have taken this as a comma 0, it might cause some confusions. So let me take that point as alpha comma 0. Okay, so this is my alpha comma 0. So that means this length must be always a. Okay. So now let us apply this idea. Similarly, here also if I draw one perpendicular, okay, so and from this point to this point the distance has to be a units only. Okay. So basically this is the foot of perpendicular. So let me just get this foot. Okay. So if I name these points as, let us say, a and b, I can get a and b directly by using the formula for foot of perpendicular. Okay. So, from that point I can just equate the distance to be a and solve for h and k. Okay. So, let me just get it. So, here for this line we have to find the foot. So, this line can be written as mx minus y equal to 0, this line can be written as mx plus y equal to 0. Okay. So, our A point will be x1 minus alpha by m equal to y1 minus 0 by minus 1 equal to minus into, in this we have to substitute the point which is alpha comma 0. So, m alpha divided by 1 plus m square. So, from this we can get the coordinates of A, which are going to be alpha minus m square alpha by 1 plus m square, comma m alpha by 1 plus m square. Now, if I simplify this, of course, I will get one point which is going to be 1 by 1 plus m square, and here it is going to be m alpha by 1 plus m square. Okay. Because these two lines are symmetric with respect to x axis, because this point is on the x axis, the other foot can be directly written by only changing the y coordinate. So, 1 by 1 plus m square, and here minus m alpha by 1 plus m square. Now, distance of h comma k from these 2 points must be equal to a, and here if we observe only y coordinate is reversed. Okay. So, when I apply the distance formula, so what do I get? I get two equations. So, h minus 1 by 1 plus m square whole square plus k minus m alpha by 1 plus m square whole square, this must be equal to a square, and similarly h minus 1 by 1 plus m square whole square plus k plus m alpha by 1 plus m square whole square, this must be a square. Now, when I subtract one from the other, see what is happening, these two terms get cancelled and this gets cancelled, and whatever we get, it will be linear in terms of k. So, whatever is the equation that we will get will be a linear equation, which means the locus of center is a straight line. So, this way we can solve the problem. Okay. So, sometimes when we want to find only the curvature, only the shape, so we do not have to go for the entire algebra, we can just kill it by observing the pattern of the equation. So, here we can observe that the equation that we are going to get will be a linear equation. So, we can confirm that it is going to be a straight line, because you can see that k square is getting cancelled here. Okay. So, this way we can solve the problem, the answer is going to be a straight line. Okay. Come on, make a note of this. Okay. So, now let us go to the next question. So, find the maximum area of a triangle inscribed in the ellipse. So, here there are two methods of solving this. One, we can assume that it is an isosceles triangle and solve it. Other, we can solve it in general sense. Okay. So, let me just do it for both cases. So, let us say I assume that the triangle is going to be isosceles triangle. Okay. So, if it is an isosceles triangle, how will it possibly be? How will it possibly be located? So, let us say this is my major axis, I can form one isosceles triangle like this. So, that point, one point is on the one end of major axis. The other could be by taking the point as one end of minor axis. Okay, so, we can take isosceles triangle like this. So, in both cases we can find the area, and we can prove that in both cases the maximum area is going to be same. So, how do we do that? So, let us say I am solving this case, and because I have taken this as one vertex, the other vertices can be taken like this: a cos theta, b sin theta, this is one. Because this is reflection about x axis, we can just reverse the y coordinate and write it. Okay. So, now we can find the area using half base into height. So, delta, which is the area, is going to be half into, this is the base is how much? 2b sin theta, and what will be the height? This is the height. Height will be how much? A minus a cos theta. So, here we can observe that half into, okay, half is anyways getting cancelled, okay, fine. So, AB into sin theta into 1 minus cos theta, this becomes our expression for the area. Now, we want to find the maximum area possible. So, let us take this variation of theta, because A and B are anyways constant. So, let us take this variable term as an objective function and maximize it. So, when we say objective function, basically we are going for the maxima minima technique of calculus. So, let me just take this as f of theta. Okay. And now, let us follow the same process of maxima minima. So, differentiate this, that will give us cos theta into 1 minus cos theta plus leave the sin theta and differentiate 1 minus cos theta, that will give us sin theta. And we want to equate derivative to 0. So, f dash equal to 0 will give us c minus c square plus s square. C for cos theta, S for sin theta. For problem solving purpose, I have taken it like this. So, let us say if I put this to equal to 0. So, S square can be written as 1 minus c square. We can simplify this and write it as 2c square minus c minus 1 equal to 0. You know how to factorize this. So, there is 2c here, there is 1 here, there is 1c here, we need minus, so it has to be minus, this has to be plus, and this must be equal to 0. So, this means we are getting two cases. One is cos theta equal to minus 1 by 2, other is cos theta equal to 1. We have to observe both cases. Now, let us check the domain of theta. See, this is the important step. Solving this like this is going to be easy for everybody, but only few of you will be able to analyze them correctly. So, whenever we get any equation, be very careful and analyze all possibilities. Let us look at the theta here. I have taken the theta as an angle which is in the above x axis region. So, which means theta must be belonging to 0 to pi. Okay. So, you cannot take theta as belonging to 0 to 2 pi. Okay. So, that means it is basically repetition. Okay. So, because I have taken angle like this. So, what are the possible cases here? Cos theta equal to minus 1 by 2 is possible when theta is 120 degrees. So, for that sin theta will become root 3 by 2. Now, cos theta is 1 only when theta is 0. So, that means here sin theta will become 0. So, now substituting these values, what will I get for f of theta? Now, if you want to verify whether this is going to give you maxima or minima, you can also go for second derivative or the monotonicity, but that is not required. You can just put the values and see which is giving you maximum, which is giving you minimum. So, if I put sin theta 0 here, so that means I am anyways getting 0, so that is going to be minimum. So, f of theta minimum is going to be 0 and f of theta maximum is going to be, we have to put these two values here. So, what do I get? Root 3 by 2 into 1 minus 1 by 2, that will give me 3 root 3 by 4. So, what will be my delta maximum here? So, from here we can conclude that delta maximum is equal to AB into 3 root 3 by 4, AB into 3 root 3 by 4. So, this is going to be our maximum area. Okay. So, now whether you choose this idea or this idea, the value is going to be same. Okay. So, this is one knowledge about isosceles triangle. So, in general when question comes based on circle or ellipse, in circle also sometimes questions come like this. Find the triangle of maximum area. So, for that also we assume that triangle is isosceles and solve it. In ellipse also we can assume it like this and solve it. but there is also one general method. So, first you make a note of this, I will solve the next one. Okay. So, what is the next method? Next method is to go for general idea. Okay. So, let us take, okay, so this is now very bad diagram. So, let us take an ellipse here. So, let us say I have taken 3 points P, Q and R. Okay. And for these I am taking the angles alpha, beta, gamma. Okay. Now, based on the parametric form of points, I will form area using formula of determinant. For example, the area of this triangle is going to be half into 111 A cos alpha, A sin alpha, A cos beta, A sin beta, A cos gamma, A sin gamma. Sorry, this must be B. Okay. Now, A can be taken common from the second column, B can be taken common from the third column. But here we need significant knowledge of determinants to proceed. Okay. So, let us say I have taken A common from second column and B common from the third column. So, that means I have to put one A into B outside. Okay. Now, let us say I apply these operations R2 minus R1 giving me new R2 and R3 minus R1 giving me new R3. Then by doing these operations, I can make sure that these two circled locations become zeros. You know this technique, you have watched our lectures on matrices and determinants. Now, further what to do? If you simplify this, you can get some form, and if there is a simple trigonometry involved there, when you finish all of it, you are going to get this expression. Okay. So, I am writing directly the expression that you are going to get. So, we will get 4 into sin of alpha minus beta by 2 into sin of beta minus gamma by 2 into sin of gamma minus alpha by 2. So, I followed a cyclic pattern here. You can also follow a different cyclic pattern, it does not matter. Okay. So, we can also write them like this: beta minus alpha by 2 first angle, and then gamma minus beta by 2 second angle, beta minus sorry okay. So, beta minus alpha, gamma minus beta and alpha minus gamma. You can also put angles like this, it does not matter. Now, this part is constant, but this part is variable because alpha, beta, gamma, all three of them are varying. Now, how to handle this situation? To handle this situation, imagine the eccentric angle on which we are taking these angles. Okay. So, here the technique that I am going to give you is a different out of the box technique, but it is a good technique, it will give you general knowledge also. Okay. So, corresponding to P, the point whatever it is there, let us name it as P dash, this is making an angle of alpha here with positive x axis. Similarly, corresponding to this point is Q dash, it is making an angle of beta. Similarly, corresponding to R, there is a point R dash on eccentric circle or auxiliary circle, and this angle is going to be gamma. Now, what is the angle which is beta minus alpha? Beta minus alpha is basically this angle, and gamma minus beta is basically this angle and alpha minus gamma is basically this angle. Okay. So, now you have understood that these are the angles that we are talking about. Now, if you add these three angles directly, they may become 0, but here we are not talking about the angles which become 0. It could also be possible that there is pi minus theta involved here. So, then sin of pi minus theta becomes sin theta, that is why we wrote it like this. So, it is also possible that sum of these three angles is pi, and for that I have explained the nature here. So, here we know that sum of these three blue angles is 360 degrees. So, if I take half of all those angles, I will get sum of all three of them to be pi, which is perfectly fitting our narrative here. Okay. So, basically we have a situation like this: a plus b plus c is going to be pi, it is already given, and we are interested in finding the maximum of sin A into sin B into sin C. These are basically the angles that I have named them as. Okay. So, basically I have taken one angle as A, one angle as B, one angle as C, you can understand it this way. Okay. So, how do we handle this problem? Now, if you look at the overall problem, it started with ellipse, went to determinants, now it is going to calculus, okay, or trigonometry. So, it is possible. Okay. So, that is why this question marks one important question of today. Okay. So, today's toughest question is this, but if we assume that the triangle is isosceles, it is very easy. Of course, you can solve it like that in the exam, but there is a knowledge that you need to learn, which you can use at later stages, especially for advanced. So, here the knowledge is going to be like this. So, we can say that using AM/GM inequality, sin A sin B sin C whole raised to 1 by 3 is less than equal to sin A plus sin B plus sin C by 3. This is AM/GM inequality. Now, by using Jensen's inequality, you know the Jensen's inequality. So, let me just explain it here. If we take the graph of sin x between 0 and pi, we will get a curve like this. So, let us say I have taken 3 points on this. These are my 3 points. If I join these 3 points, I will get a triangle, and let us take this point as A comma sin A, and this point as B comma sin B, and this point as C comma sin C. Okay. Now, when I take centroid of this, so let us say I have taken centroid somewhere here. Let us say here is the centroid. Now, what are the coordinates of centroid? Coordinates of centroid go like this: A plus B plus C by 3, comma sin A plus sin B plus sin C by 3. This is going to be simple formula for centroid. Now, corresponding to this G, if I draw one ordinate, what is the meaning of ordinate? Perpendicular drawn to x axis. Now, what is the x coordinate of this? A plus B plus C by 3, comma 0. Now, corresponding to this, if I take this height, let us say I name this point as P. Now, we already used P earlier, so let us take something else. So, point as M. So, coordinates of M will be somewhat like this: A plus B plus C by 3, and here we have sine of A plus B plus C by 3, right. These are the coordinates. Basically, I am also explaining Jensen's inequality here. So, if you understand this logically, you might have never proved the Jensen's inequality. Of course, I am proving it here, but in this context, if you understand the logic, you can apply it anywhere whenever you are needing it. So, here you know that the height of the centroid G is definitely smaller than the height of the M. So, we can say that out of these two heights, out of this and this, which is greater? Of course, this is greater. So, here we can say that this is further less than equal to sine of A plus B plus C by 3. I hope this idea is clear. Okay. So, now further how do we proceed? We know that A plus B plus C is already pi. So, just put pi here. So, this will give me sine of pi by 3, which is going to be root 3 by 2. Now, that means we can say that sin A into sin B into sin C is always less than equal to root 3 by 2 whole cube, which is going to be 3 root 3 by 8. Okay. So, you can also logically argue that saying, sir, if A, B, C are equal, then I will get the maximum value, but that is layman's talking. Okay. So, you need to know the methods to solve the questions. So, I hope you liked this technique. Now, let us go back. So, here we are saying that this entire expression is going to be less than equal to that value 3 root 3 by 8. So, we can say that delta is always less than equal to half into AB into 4 into 3 root 3 by 8. Now, you see what is the value that we are getting? We are basically getting AB into 3 root 3 by 4, which is also same as the earlier one. Okay. So, it is better to know the general methods. Okay. But from mains point of view, nobody is going to ask you this question, but from advanced point of view, it is better to learn. Okay. So, but in the exam, if you want to solve a question, you can also take it as isosceles and solve it. Both ways you will get the same area. Okay. So, I hope you are liking these techniques. Come on, take a snapshot of this method. This also and this also. This is more important page. Now, let us look at some more questions. So, here SS dash are foci, P is any point on the ellipse. Prove that the locus of incenter of triangle SPS dash is another ellipse. Find its eccentricity in terms of E. So, how do we do that? The idea is going to be this. Let us say there is this triangle and this is my P, this is S dash, this is S. Okay. So, I think if we draw the triangle here, it is better. So, because that page we will use for problem solving. So, let us take P as A cos theta comma B sin theta and this S dash as minus AE comma 0 and this S as AE comma 0. Now, we know that the length of this side is going to be A into 1 minus E cos theta, because this is the formula for focal length, and this is going to be A into 1 plus E cos theta, and this length is 2AE. So, we can straight away apply the formula for incenter and solve it. So, if I take the incenter as let us say x comma y, so I can get the coordinates of x and y directly. Okay. So, you know the formula Ax1 plus Bx2 plus Cx3 by A plus B plus C, you know that idea. So, let me just apply it here. So, x is going to be 2AE into x1. So, 2AE into A cos theta plus A into 1 plus E cos theta into AE plus A into 1 minus E cos theta into minus AE and divided by sum of all three sides, which is going to be 2AE plus A plus AE cos theta plus A minus AE cos theta. Now, let us just simplify this. So, what do we get here? We get A square E common, we get 2 cos theta here, and here we are getting 1 plus E cos theta, and here 1 minus minus 1 minus 1 plus E cos theta. Okay. So, divided by here luckily A cos theta got cancelled, and if I take 2A common, I am getting 1 plus E. Here E cos theta is getting 1 is getting cancelled, E cos theta is not getting cancelled. Okay. Okay. So, further we can also take 2 cos theta common. So, we get something like A square into E into 2 cos theta common into 1 plus E. Is that fine? Okay, so let me just see that. If I am taking A into 1 plus E cos theta, it must be multiplied with AE, this also must be multiplied here. So, we are getting a simple form here. Okay, so that is fine. So, 1 plus E by 2A into 1 plus E. So, we are getting 2 cancelled and A also cancelled, 1 plus E is also getting cancelled. Okay, very beautiful. So, this means we got a relation like x equal to AE into cos theta. Okay. Now, similarly we can get y coordinate. Okay. So, let me just check if I have done any mistake here. So, this seems fine till now. Okay. So, let us find the y coordinate here. So, it will be 2AE into b sin theta and remaining terms become zeros, and in the denominator anyways we are getting 2A into 1 plus E. So, 2A got cancelled here. So, we can straight away write y as BE sin theta. Okay. So, this means if I eliminate cos theta and sin theta, I can straight away get the equation of required locus. So, cos square theta plus sin square theta, what is it giving us? X by AE whole square plus y by BE whole square is equal to 1. Beautiful. It is just a matter of constant here. So, we are just multiplying the existing ellipse with a constant and getting the required ellipse, which means the eccentricity of this ellipse and the original given ellipse are basically same. Okay. So, here we have proved that the locus is going to be another ellipse, of course we proved it, and eccentricity in terms of E, of course required eccentricity is same as the original eccentricity. Okay. So, this way we can solve the problem. I hope you have learned the method. So, here in this method there is not much creativity that we have applied, it is just simple systematic approach. Okay. So, come on, make a note of this. Okay. So, next problem. So, if normals at these 4 points are concurrent, then show this relation. So, how do we do this? In general, if I take any point as so, okay, for that you need to understand this idea of conormal points. Conormal points is definitely not in the syllabus of mains, it is only for advanced. So, suppose on ellipse, there are normals at 4 points, let us say there is this normal and there is one more normal here, and let us say there is one more normal here. Okay. So, excuse my diagram, and there is one more normal here. So, let us say these normals at these 4 points are intersecting at a point. So, PQRS, these are the points at which we have drawn normals. If all these 4 normals pass through a single point, that means all 4 normals are concurrent. So, then PQRS can be called as conormal points. Now, if question comes on conormal points, for instance this problem. So, if question comes on conormal points, now the equation of normal the equation of normal that you will be using to solve the question will depend on the given requirement of the problem. So, here in the given problem we have to comment about the angles, we have to comment about the eccentric angles. So, we start the equation of normal in parametric form where eccentric angle is involved. Okay. Now, if else in some questions slopes may be involved, in some questions points x1, y1, x2, y2, x3, y3 may be involved. In those situations we have to start from those ideas only. Okay. So, here we will start with any one equation of normal. So, let us say I take equation of normal like this, ax by cos theta minus by sin theta is equal to a square minus b square. Now, if all these 4 normals are passing through a single point, let us say I take this point as some h comma k. So, then that means this h comma k must satisfy this equation. So, I will write ah by cos theta minus bk by sin theta is equal to a square minus b square. But it is not a single normal, it is many normals. So, that means this equation must be satisfied by 4 values of angles theta 1, theta 2, theta 3, theta 4. So, that means I have to somehow convert this equation into an equation where I am talking about the roots of theta. So, for that I am using this idea. I will put cos theta is equal to 1 minus t square by 1 plus t square, and I will put sin theta equal to 2t by 1 plus t square, and what is my t here? T is going to be tan theta by 2, and then the number of solutions and the kind of solutions that I will be talking about will be based on these the values of t. T1 means tan theta 1 by 2, T2 means tan theta 2 by 2. So, this way I will start the workout, and I will try to convert this into a polynomial equation where I can talk about the sum of roots, product of roots, and all properties of roots. So, just substitute it here and simplify. So, what do we get? ah by cos theta, so 1 minus t square here, 1 plus t square here. Okay, next minus bk by sin theta, so 2t here, 1 plus t square here, equal to a square minus b square, which is same as a square into e square. Okay. Now, if you notice, I have converted this into a polynomial. I just have to cross multiply and simplify it, convert that into standard form. So, let me just take LCM and simplify. So, here ah into 2t will come here. So, 2t plus 2t cube minus bk into this term will come here. So, it becomes 1 minus t power 4, and here a square e square into 1 minus t square into 2t. Okay. So, we can also simplify it further. So, 1 minus t square into 2t will be 2t minus 2t cube. Okay. Now, let us collect all coefficients based on the powers. So, there is only one t power 4 term. So, bk into t power 4 plus t cube, if I take common, I get 2ah here, and from here I will get plus 2a square e square. Now, if I take t square common, there is no t square here, if you notice. So, the coefficient of t square is 0. And what about t term? There is one t term here, there is another t term here. So, that will be 2ah minus 2a square e square. Okay. Now, the constant term. Okay, there is only one constant term, which is the minus bk. This must be equal to 0. So, this is one polynomial equation in terms of t of degree 4. So, it will have 4 roots, which are t1, t2, t3, t4. So, if roots are t1, t2, t3, t4, you know we can apply properties of roots here. So, what would be sum of all roots? We name it as S1. So, S1, which is going to be t1 plus t2 plus t3 plus t4. Now, what exactly is this t1? Tan theta 1 by 2. This is tan theta 2 by 2. You know it. Now, sum of all roots is going to be minus 2ah plus 2a square e square divided by coefficient of highest power, which is bk. Now, similarly, what about S2? S2 means sum of the products of roots taken 2 at a time. So, S2 is going to be 0 because t square has coefficient 0. Similarly, S3 will be how much? S3 will be minus 2AH minus 2A square E square divided by BK. Now what about S4? S4 will be equal to the last constant term minus Bk divided by the highest powers coefficient, which is Bk. Now this is going to be minus 1. We applied the properties of roots. Why did we apply it here? Because we are interested in deriving a formula for sum of all these 4 values. So that means I am interested in applying tan of A plus B plus C plus D. You know that formula, you have learned it in trigonometry. So we can do it like this. Tan of, let us say I have taken theta 1 by 2, theta 2 by 2, theta 3 by 2, theta 4 by 2. This is going to be, this is going to be S1 minus S3 by 1 minus S2 plus S4. This is standard formula of sum of 4 angles of trigonometry. Okay. So now here what are the simplest values that we see? S2 and S4 are very simple. So let us just observe the denominator first. Okay. So if I just observe the denominator, what am I getting here? 1 minus 0 minus 1, and denominator is going to be 0. Can the numerator be 0? Let us just check that. So is S1 and S3 equal? Of course they are not equal, because there is a difference of sign here. So they are definitely not equal. So we are basically getting a form which is constant by 0. So that means whenever we get constant by 0 for tan of theta, what could be the value of theta? It must be odd multiple of pi by 2. So we can say that this summation theta 1 plus theta 2 plus theta 3 plus theta 4 by 2 is going to be odd multiple of pi by 2. Now if we cancel 2, we have basically proved the requirement. Okay. So this way we can proceed with the problem. So there is also another question in today's lecture where we need the point. So there we will not start the problem with this formula, we will start with the point formula. Okay. So I hope you are enjoying these techniques. Come on, take a snapshot of this. This page also. This page also. Okay, next. So find the points on the ellipse which are closest and farthest from the line. So in general, this kind of question is actually common. We have done similar questions in parabola also. So basically there is one line here, x plus y equal to 7. So let us say we have one ellipse here like this, and we have one line here. Okay. So the equation is given here. Now if I convert this into standard form, I am getting x square by root 6 whole square plus y square by root 3 whole square is equal to 1. So basically this length is going to be root 6, this length is going to be root 3. So we definitely know that this line is not going to intersect this ellipse, because the x-intercept itself is 7 here, y-intercept is also 7. So there is no way they will meet. Okay. Now if at all they meet, then minimum distance will become 0 if they are intersecting. Okay. And if they are touching, then also it could be 0. So here we can understand one simple idea. Now to find the minimum distance of any point on the curve with respect to any line, what is the idea? We have to look for tangent which is parallel to this line, tangent to the ellipse but parallel to this line. Okay. So here if you observe, there will be one tangent here which will be parallel to this line. Okay. This will be the shortest distance. Now farthest or largest distance will come at another point which is again at which again the tangent is parallel to this line. So from here to here we can get the maximum distance. Okay. So then how do we apply this idea? We just have to get the equations of tangents having the same slopes and then find the distance. because we are interested in, okay, if we are interested in the distance, we can directly go for the equation of line and find the distance between parallel lines. But if we are interested in the points, then from the tangent we should be able to derive the equation, derive the coordinates of the point. So, let us just do it. So, here we observe that the slope is going to be -1, we observed it, and we know the equations of tangents to this curve, but in slope form. So, y equal to mx plus minus root of a square m square plus b square, this is the form. So, that means here we are going to get y equal to minus x plus minus root of what is a square 6, 6 into m square is going to be 1 plus b square is how much 3. So, basically we are getting root of 9 here. So, I am getting lines like this, x plus y equal to plus minus 3. So, if I am interested only in the distance, okay. So, let us take this distance as d1, this distance as d2. So, our d1 will become mod of 7 minus 3 by root of 1 square plus 1 square. How did I apply this formula? It is basically the distance between parallel lines formula. And similarly, d2 can be calculated in similar manner, but with plus sign. Okay. So, you know what these values are going to be. This is 4 by root 2, so that means it is 2 root 2. This is 10 by root 2, which is 5 root 2. So, we got the distances. If we are interested in distances, we just killed it, but we are interested in the points. So, let us say this point is h comma k. Okay. So, you know how to get the equation of tangent at a point. At a point means point must be on the ellipse. So, it is going to be S1 equal to 0, which will be xh by a square, that is how much 6, plus yk by b square, which is going to be 3, equal to 1. Now, let us just compare this directly with the equation of tangent. Now, the tangent which is lying in this first quadrant will have plus as the coefficient of 3 here. So, which means we can write it as x plus y must be equal to 3. So, we can directly compare the coefficients here. Okay. So, h by 6 by 1 equal to k by 3 by 1 equal to, it must be 1 by 3. So, what is the point that we are getting? H we are getting as 2 and k we are getting as 1. So, the first point, this point is going to be 2 comma 1. And similarly, when we find for the other, okay. So, what do we get here? For the other, we just have to take minus 3 here. So, that means the other point is going to be minus 2 comma minus 1, okay. And these are basically going to be diagonally opposite points. In fact, this is one of the properties of the diameter, okay. At the ends of diameter, whatever are the tangents, those tangents are always parallel. So, the moment we realize that any two tangents are parallel, so by joining these two, by joining this point and this point, we should be able to get a line which is the diameter of the ellipse which is passing through the center. So, if this is a cos theta b sin theta, this is going to be minus a cos theta minus b sin theta. Okay. So, that way we can solve this problem. Okay. So, I hope you enjoyed the problem solving techniques of today. So, with this we will close the chapter ellipse. We have tried to solve as many problems as possible in the lectures only. But even then, after that, when you practice at your home, if you still find some problems or if you still find some discrepancies or misconceptions, or even if you are stuck at any problem, you can always post it on the app. We are always there to answer. Now, having completed the chapter, still there is a large task that is upon you, which is to develop skill set of problem solving, which you will gain only after practice. Okay. So, we will meet again in the next lecture with another chapter, which is hyperbola. Until then, have a great learning day. Learning shall never stop.